So show that the sequence n over n squared plus 1 is decreasing. So you could do this with inequalities, but it's going to be a lot more difficult with inequalities. They do this in your book, and you can see it for this example, but it's not very nice. So I want to tell you the other way. Instead of doing these inequalities, you could turn this into a function. Functions have the same terminology, increasing and decreasing. How do you know when a function's increasing?
Output values are getting larger.
Uh-huh. Yeah. Another way, so along those same lines, the derivative will tell you that, right? If the derivative is positive, your function's increasing. If the derivative is negative, your function is decreasing, right? So all I've got to do is take the derivative of this function. So let's do that. What's the derivative of this?
X squared
Minus 2x times x.
over x squared plus 1 squared.
Okay, so let me go ahead and simplify that. Yeah, so we did the quotient rule, right? And this will be x squared minus 2x squared, so it'll be 1 minus. So I need to know if this is positive or negative. This is a fraction. Let's start by looking at its denominator. Is the denominator positive or negative? Positive. Why do you say that? Because it's squared, right? A square number is only ever positive or 0. It's not negative. So this is only going to be less than 0 when the numerator is negative. So 1 minus x squared is less than 0. Or 1 is less than x squared. So this tells me that my function is decreasing on this interval 1 to infinity. But that's exactly what we need to know because my values of n are in this interval 1 to infinity, right? So f sub n, which was n over n squared plus 1, is decreasing for n greater than or equal to 1.